Hello students, welcome to Unit 9 Notes, Section 10.3. As you can tell, there's quite a bit of notes here, so you're definitely going to want to take a pause and write down this warm-up. It really has a lot to do with 45-45-90s and 30-60-90s in terms of triangles and squares and rectangles and whatnot. Yeah, take some time to write some of this down. The notes will be quick. This warm-up probably takes most of the time. What I will do is I will divide it up so that you can see what goes to what. So I'll just draw this down, and that is how everything's separated for the notes. Okay? All right, but once you're done writing this down, we'll move on. And so we are finding the areas of regular polygons. So it's really cool is let's go back to this one for 1 second. Now I got the answer 50 feet squared. Now notice what I did. I actually used 45-45-90s to get these side lengths, which are 5 square roots of 2, 5 square roots of 2, and 10. So with the 5 square root of 2 times the 5 square root of 2, that gave me 25 square roots of 4, which was 25 times 2, which is 50 feet squared. Okay. Now, based on the last example we did, the last lesson we did, in any particular kite or rhombus, you can do 1/2 diagonal 1 times diagonal 2. Well, check this out. Isn't this a rhombus? It's a square. I know it's a square, but all squares are rhombuses. Not all rhombuses are squares, but a square is a rhombus. So this diagonal is 10. This diagonal is 10. So we are going to do 1/2 10 times 10. 1/2 of 100 is 50. So the point of this lesson is, to use different strategies, but really to use 45-45-90 and 30-60-90 only when it's most necessary to do so. Okay, so here's a regular polygon. Let's take a look. Here is a hexagon. Let's look at the anatomy of a hexagon. We have a center, just like around a circle. There's also a center of a hexagon. There's also these things that go from the center to the edge that are what we call radiuses or radii. And notice why we call that one a radius. Why, when we go from here to here, don't we call it a radius? Well, look, it hits the edge of a circle. Look at how in a regular six-sided figure, in a regular meaning it's perfect. All the sides are the same length, all the angles are the same measure. Everything is perfect about it. You notice that all of its edges lie in the circle, making this a radius because it's truly a radius of a circle. So it's also a radius of the hexagon. Whereas an apothem doesn't reach the edge. An apothem is what goes from the center and it goes down perpendicular to the edge of a regular polygon. And the reason for that is that we need to find the area somehow, so we use a set of triangles. So let's think about this outside the box. If I want to know the area of this hexagon, I could add all 6 triangles up. Now a triangle is 1/2 base times height. So 1/2 base times height. Oh, sorry, base times height. So it's really 1/2 of this base times this height. And it's 1/2 of this base times this height. It's 1/2 of this base times this height. 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 Now, they're all the same heights. So you can almost factor that height out and just say it's 1/2 of that base and 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 that base. Well, it's 1/2 height times all of those bases. What are all those bases? It's what we call the perimeter. So it's 1/2 height times all my bases. AKA it's called 1/2 apothem times perimeter. So the area of a regular polygon is area of a regular polygon is 1/2 apothem times perimeter. Whoops. And what you need to do is you need to add everything together around the edge and then multiply that by apothem and then find half of it. And that's it. That's how you find the area of a regular polygon. It can be a hexagon. It can be an octagon. It can be a decagon. It can be any type of polygon with pentagon, 5 sides, 5, 6, 7, 8, 9, 10, 11, 12, 13. It can be any amount of sides. You just have to do 1/2 apothem times perimeter. A lot of the times, though, we need to break it up and we need to find out angles because we might not be given everything we need. If we're given that a base is 10, well, then we need to break this into 5 and 5. That would make this length 10 and that length 10 because it's really 10, 10, and 10. It's an equilateral triangle. Making this right here 5 square roots of 3 based on my 30, 60, 90 triangle. So that's our focus today, is really breaking it apart, getting my angles, figuring out what the apothem and the perimeter are based on maybe using 30, 60, 90s or 45, 45, 90s. Okay, I'm going to try to keep that as short as possible. So this first question, the figure at the right is a regular pentagon with radii and an apothem drawn. So it's a regular pentagon. Find the measures of each numbered angle. So how do I find the measure of any of these angles? How do I find this angle? How do I find this one? 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 And how do I split it in two, right? Because there's 2 of them. Well, I'm going to show you a formula I think we've already used. The area, there's 360 degrees in a circle. There's also 360 degrees in the inner part of a hexagon, pentagon, whatever, octagon. So what you're going to do is you're going to do n minus 180, okay, and that's going to give you the amount of degrees where n is the number of sides. So you do, oh, I'm sorry, n minus 2, my apologies, I wrote the wrong thing, n minus 2 times 180. I can't believe I just did that. Okay, we've used that before, n minus 2 times 180. So you're going to take 2 sides away. Think about a triangle. N minus 2, so 3 minus 2 because a triangle has 3 sides. So it's 1. 1 times 180 is 180. So that's how you find out how many degrees are on the inside per angle. If you do n minus 2 times 180, and then you divide it by n, you will get, oh, so that's how many total degrees are in its angles here. I apologize. So in orange, let me change the style here. So in orange, that n minus 2 times 180 gives you these angles. My bad. It's the interior angles right here, not the central angles. So collectively, it would be the combination of all of those. Now to find central, what you do is n minus 2 times 180 divided by n, because that will give you each one of those separate angles on the inside. it'll give you these angles. So n minus 2 times 180 and n minus 2 times 180 divided by n. So let me do some of this math. So in orange, it's a 5-sided figure, so it's going to be 5 minus 2 times 180, which is 3 times 180. So, whoops, 3 times 180. They all add up to 540. So they add up to 540 degrees. I apologize, I made another mistake. 540. What I meant to say is not what I said. So it's 540 total degrees. Now if I do n minus 2 times 180 divided by n, so if I divide that by 5 now, because it's 5 sides, I get 108. So my apologies. It is late and I am doing 108. And I am still trying to get all these notes done. So 540 is the total amount that each of these add up to collectively. But that means that each one of these is actually 108 degrees. So together, all of them add up to 540, but each one separately is 108. Okay? And now, the way to find central angles is to just divide by the number of sides. Because if you do 360 divided by, because all central angles add up to 360, divided by there's 5 sides or 5 angles. So 360 divided by 5 is 72. Yep, 72. Whoops, dropped my calculator. So that is 72 degrees. So these are all 72 degrees. So angle 1 is going to be 72 degrees. And I don't even know where to put this. That's good, I think. Okay. So now let's take a look. This one looks like it's split up. So instead of 72, I'm going to divide it by 2. So 36 and 36. So it looks like angle 2 is 36 degrees. So angle 1 is 72, angle 2 is 36. And oh, look at angle 3. We're going to split 108 in half. So we're going to call it 108 divided by 2. So it's 54 degrees and 54 degrees. So really, we can split them up as much as we want to, as long as we divide them properly. So the whole thing was 360 in the center, which was 72, 72, 72, 72, 72. But I had to divide 72 in half because it was split by an apothem. Then n minus 2 times 180 gives me all of these angles. So these add up to 540 total. Divide it, though, by the amount of sides, or in this case, triangles I have, and we're going to have, well, yeah, so 5 sides, 5 angles. So divide it by the 5 sides, and we get 108. That means that this is 108, that's 108, that's 108, 108, and 108. But then I had to split 108 in half because it's talking about that whole thing being 108. So collectively, these two add up to 108, making each 154. Divide by 2. This had to be split up, so 36 and 54. Now let's take a look. This triangle here on the inside, 36 plus 54 plus 90 is 180 total degrees. So it really all worked out. Okay? That was a lot, I know. But all right, at the right, we have a portion of a regular octagon. It has a radii and apothem. It's regular, so it's all good to go. It's perfect. So find the measure of each numbered angle. So first thing I'm going to do is 8 minus 2 times 180 divided by, divided by 8. So I'm going to do 6 times 180 divided by 8. So 6 times 180, 6 times 180 divided by 8. So I get 135. So this is 135 degrees. This is 135 degrees. All 8 angles will add up to 135. So again, 8 minus 2, because there's 8 sides to an octagon. So that's going to be 6. 6 times 180 divided by 8. So it's 3/4 of 180, which is 135. So now I'm going to have to split this one up. So divided by 2 is 67.5. So this part right here is 67.5 degrees, because only a portion of it, it's half of it, right, got cut in half. These are cut in half, so 67.5 degrees and 67.5 degrees. This one's 67.5 degrees as well. And now I'm going to break my central angles up. So I'm going to do 360 divided by 8, which ends up being 45 degrees. So those are my central angles. So we have 45, we have 45, we have 45, and then half of that is 22.5 and 22.5 degrees. All right, we found those. Last thing we do want to do is probably write them out, because I'm taking the short road here. So I'm going to say measure of angle 1, measure of angle 2, measure of angle 3. Measure of angle 1 is 45 degrees. Measure of angle 2 is 22.5 degrees, half of it. Measure of angle 3 is 67.5 degrees, which is half of 135. All right, nice work. I'm going to label these up here too, because I think I didn't write them out the way I should have. So measure of angle 1 is 72 degrees. 2 is 36. 3 is 54. Yep. All right. Next example, we have a regular decagon, which is ready for a decagon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Deca meaning 10. So deca, we have a decagon. Oh, looks like this froze a little bit. Okay, so it's a 10-sided figure. So it doesn't really matter, because it wants me to find the area, but it already gave me the pieces I need. So area is 1/2 apothem times perimeter. So area equals 1/2 apothem. Now let's find the perimeter. This is why it matters. Perimeter equals 8 inches times 10 sides. So perimeter is 80. 80 inches. Most students will use the number 8, not 80, and that's where they make a mistake. So you don't want to do that. You want to use 80 for your perimeter, not 8, because 8 is only one side. So this can be half of 12.3 inches and 80 inches. So for me, I'm going to do this all out. I'd rather do half of 80, which is 40. So 40 times 12.3, which is 492 inches squared. And we're done. So next one, you have a pentagon with sides that are 11.6. So you do 11.6 perimeter equals 11.6 centimeters times 5. I think it's 58. Hold on. Yeah, 58. So perimeter is equal to 58 centimeters. Okay. So you have the perimeter. You can now do area, which is 1/2 apothem times perimeter. So area is 1/2 apothem, which is 8 centimeters. Times perimeter, which is 58 centimeters. And so 8 times 58 times 0.5. So we get area equals 232 centimeters squared. And we're done. All right. Last slide. So here we have a boat used for racing, which has bodies made of honeycomb, of regular hexagonal prisms, sandwiched between 2 layers of outer material. At the right is an end of one of the hexagonal cells. Find its area. So here you have an example of the boat, and you have inside what that looks like. So you have all of these hexagons right here. Okay, so we want to find the area of one of them. So here's an enlarged version of that hexagon. It's in millimeters, very, very small. But it looks like we have a side length of 10. So 10, 10, 10, 10, 10, and 10. So cut that in half, and you have 5 and 5. And why did we do that? Well, if we do 360 divided by 6, we would have 6 central angles, each one being 60 degrees. Cut the 60 degree in half and make it a 30. So what we're doing is we're doing a 30, 60, 90. So in a 30, 60, 90, we have H equals S times 2 and L equals S times the square root of 3. So we have let's see, we have the short side, which is opposite the 30-degree angle, which is 5. It's all about the short side. So H equals 5 times 2. So H equals 10 centimeters. Well, that makes sense because we have a 10. This is an equilateral triangle. So each part of that's 10. So that does make sense. That's not even what I'm looking for, though. I'm looking for this long side. So L equals 5 times the square root of 3. So L equals 5 square roots of 3 centimeters. So that's what this A is. A is 5 square root of 3. Oh, I'm sorry, millimeters. So this is in millimeters, not centimeters. It's even smaller. Okay. So now I have the apothem. the perimeter, we have a side length of 10, so perimeter is 6 sides is 10 millimeters times 6 sides. So perimeter is 60 millimeters. So now area is equal to 1/2 apothem times perimeter. So area is equal to 1/2 5 square root of 3 times 60. So area is equal to 30. So this is going to be 30, right? Half of 60 is 30. So 30 times 5 square root of 3. I think that's the easiest way to do this. So area equals 150 square root of 3 millimeters squared. Because 5 times 30 is 150. All right. And that is it for that problem. So the last one is a hexagon side that has 16. Find the area of the hexagon. So I'm going to copy and paste this because this is fine. I'm just going to change my numbers because it's the same thing with different numbers. All right. And I hope this doesn't confuse you, but I'm going to change the numbers for it. But right now, all of these things can pretty much stay the same other than the numbers. So, all right. So instead of, it has a side that's 16. So I'm going to get rid of 5 and make that 16. Okay, so 16 feet. So 16 times 2, 16 times 2 is 32 feet. And that makes 16 times the square root of 3, 16 square roots of 3 feet. Now the perimeter is not 10 millimeters. It's going to be 16 feet times 6. So 16 times 6 is 96 feet. All right, so I found my new perimeter and my new leg. So right here, just be careful, this is my apothem. Just like we found above. So here we have 16 square roots of 3. And 96. And so I'll do half of 96, which is 48. So 48. You know what? At this point, I can find just half of 16, which is 8 square roots of 3 times 96. And 96 times 8 is 768. Square root of 3 and feet squared. So all I did was change the numbers, but I followed the same pattern. And that's it. So you have some problems here. There is no, for this lesson, There is nothing you can do on iExcel. So what I'm going to have you do is I'm going to have you actually do these problems. So you have to do these and upload them to Google Classroom. Upload these to Google Classroom. All right. And it's not many, it's like 3 or 4 pages. Yeah, 1, 2, 3, 4 or 5 slides. So that's your only homework, and you'll get full credit if you do it. Okay? All right. This lesson's tough, so if you need help, book me, okay? Good luck.